fractions together, we're going to follow this rule right here. If you had a over b times c over d, the product of that is going to be a times c in the numerator over b times d in the denominator. So basically you're going to do what we call multiplying across, where you just take the product of the numerators and you keep that in the numerator, and you take the product of the denominators and you leave that in the denominator. So let's try some examples. If you had 3 over 2 times 4 over 3, we'll go ahead and multiply the numerators together. 3 times 4 is 12. Then we'll multiply the denominators together. 2 times 3 is 6. And 12 over 6 is 2, right? Over here we have 2 times 3, we have 2 over 8 times 3 over 5. So we're going to do 2 times 3, which is 6. And then 8 times 5, which is 40. And 6 over 40, we could take a 2 out of both of these, right? So we're going to be left with 3 over 20. Okay, and then also I just want to show you, with this one over here, there's a trick you can do. See how there's a 3 over here and a 3 over here? You could sort of just cancel those, because these are going to both end up, this one's going to end up on the numerator and this one's going to end up on the denominator, so they're going to divide by each other basically. And you could also cancel over here. This 4 is going to end up over this 2, and we know that 4 over 2 is 2. So another way to write that, here I'll show you over here. You can think about it like this. If you had 3 over 2 times 4 over 3, that's going to equal 3 times 4 over 2 times 3. And see how these are now on top of each other? Or this one's above this one, and this one's above this one, and so 4 over 2 is just 2. So that's another way you can think about that one. And then another shortcut you can do over here for this problem is you could have simplified this fraction before we did the multiplication. You can see 2 over 8 is the same thing as 1 over 4. So then if we were to do 1 times 3, that's equal to the 3 over here, right? And then 4 times 5 is equal to 20. So that might have been a simpler way to do this problem, is to simplify the fraction before we started. So let's talk really quick about doing division with fractions. It's actually almost the same as multiplication, there's just one extra step in between. So if you had the fraction 3 over 4, and you had that divided by 5 over 3, well, what would you do? Well, one thing you can do, if this looks kind of confusing to you, you can rewrite this as just 3 over 4 divided by, like that, 5 over 3, right? And so when we have division like this, what you're going to end up doing is you're going to end up multiplying instead by the reciprocal of this fraction over here. So we're going to change this problem into this problem over here. 3 over 4 times 3 over 5. And this would give you 3 times 3 in the numerator, right? That's 9. 4 times 5 in the denominator, that's 20. And your answer would be 9 over 20. And you can't simplify this anymore. And so to sort of make sense of why we're allowed to do this and why that's how we do these problems, let's take a look at what happens when you multiply a number by 1/2. So if you had 4 times 1/2, you could rewrite this as 4 over 1 times 1/2, right? Because 4 over 1 is just 4. And so if we do our rule, right, multiply across, we get 4 over here, and 1 times 2 is 2. We get 4 over 2. 4 divided by 2 is 2, right? And so 4 times 1/2 equals 2. That's the same as if you would have done 4 divided by 2 over 1, right? 4 divided by 2, we all know that 4 divided by 2 is 2. And now we know that 4 times 1/2 is also 2. So it turns out dividing by 2 over 1 is the same thing as multiplying by its reciprocal, 1 over 2. So let's talk about adding and subtracting fractions now, which can be a bit more tedious than multiplying and dividing. So the rules right here, if you had a over b plus c over b, you're going to end up with a plus c over b. So you're going to notice that the denominator, well, it has to be the same amongst the fractions that you're adding. That's just how it is. And as well as that, the denominator stays the same in your answer. They don't get added together. They don't get multiplied together. They just stay as b. And in the numerator, the numerators just get added together. So let's do an example. If you had 1 over 4, and you're going to add 1 over 4 to that. So these are both 4's in the bottom, so that's good, and then we just do 1 plus 1 in the numerator, which is 2, right? And then we have 2 over 4, which simplifies to 1/2. And this sort of makes sense, right? Because if we had, remember our pizza from earlier? If we had 1/4 of a pizza and we added another 1/4 of that pizza, now we have like half of a whole pizza, right? So 1/4 plus 1/4 is 1/2. So let's try a problem where the denominators are not the same, like here. So this denominator is a 2, this one's a 5. So if they're the same, we're going to have to make them the same. And to do that, we're going to find the lowest common denominator. So what that is, that's basically the lowest multiple of these denominators that is the same. So one way we can do that is we could just look at all the multiples of 2, right? So that's going to be 2, 4, 6, 8, and 10. And we could keep going, but you'll see why I stopped there. And then we'll look at all the multiples of 5, right? So we have 5, 10, 15, etc. But I can already stop because we've already found one of these that are the same. So the first ones that were the same was the 10, so that's our lowest common denominator. So basically we just want to make both of these have a denominator of 10, and to do that we're going to multiply these fractions by a number over that same number. Right, so to get 2 to be 10 we need to multiply it by 5, but if we do that to the bottom we've got to do it to the top as well. And so 7 times 5 is going to be 35. And 2 times 5 is going to be 10, right? Over here, we have to do the same thing. To get 5 to equal 10, we have to multiply that by 2. And so if we do it to the bottom, we're going to do it to the top. 3 times 2, that's going to be 6. And 5 times 2 is going to be 10. So now we have both of the denominators the same. And now we can do our addition. So 35 plus 6 is going to give us, let's make some room right here. It's going to give us 41. And then remember, we just leave the 10 like that. And that's our answer, 41 over 10. And so if you had subtraction, just keep in mind that instead of adding the numerators, you just subtracted the numerators. And so you may have noticed that to get this 10, we could have just multiplied the denominators together. And so multiplying the denominators together will always give you a common denominator, but it won't always be the least common denominator. And just to show you an example, if you had 2 as one of your denominators and 6, and you multiplied them together, you'd get 12, right? And that is a common multiple of both of these numbers. But it turns out the lowest common denominator, right, like if you had some fraction like this, the lowest common denominator here is actually 6, because 2 goes into 6 and 6 goes into 6. So multiplying them together is often the fastest way to get a common denominator, but it doesn't always give you the lowest common denominator. So let's try another problem. Right here we have 7 over 12 minus 5 over 18. Notice that we have a subtraction problem now. And so that isn't really a big difference. All you'd have to do really, like in our formula over here, is change all the pluses to a minus. And that's just the rule for subtraction. So over here we have to get the lowest common denominator, right? But with some problems, finding all the multiples of 12 and 18, or whatever other problem you might have, sometimes that'll take too long, and you might end up having to do it a bunch of times, and that's not the best way sometimes. So another thing you can do is you can get the prime factorization of each of these, and then you'll see where we go from there. So if we take 12 and we get the prime factorization, just like before, we end up with 2 times 6, and then 2 times 3, right? And then we'll take 18. Same thing over here, we do 2 times 9, and then 3 times 3. And so this time we're going to do something different. We're going to take a look at all the ones that they share. So they have a 2 in common, and they have a 3 in common. And then whatever's left over, this 2 and this 3, that's what we have to multiply the other number by to get a lowest common denominator. So this 18, we're going to have to multiply that by 2, and this 12, we're going to have to multiply that by 3. And that would give us 36 in either case. So we're going to multiply this 7 over 12 by 3 over 3, because of the 3 that we had here. And we're going to multiply this 5 over 18 by a 2 over 2. And then that's going to give us a 21 over 36. minus a 10 over 36. Which, these have the same denominators now, so we just have to do 21 minus 10, which is 11, right? And so that's how you do this problem.